Hello grade 10, this is the continuation of our topic in patterns and sequences. Today I will teach you about teleportation. To be at a certain place in an instant. This is one of my examples in our previous video, the what comes next activity, remember? The question was, what comes next in this figure sequence? Or what is the fourth figure? So what did we do? We analyzed the figures and obviously it's a growing pattern. The number of triangles increased by 1. At the same time, the number of matchsticks increased by 2. So the fourth figure must have 4 triangles having 9 matchsticks. If I ask you how many triangles on the fifth figure, it's easy. The answer is 5 triangles. How many matchsticks are there? Just add 2 to the previous 9 matchsticks, so the answer is 11 matchsticks. So it keeps on adding 2 over and over again. Now here's the challenge. How many matchsticks are there in the 20th figure? What? Ang layo nun. We can still manually add 2 until we reach the 20th figure, right? But what if the question asks for the 100th figure? What? Ang layo nun. Ulit-ulit. There must be a way to teleport at an instant to reach the 20th or the 100th figure. Exciting, right? Yeah, come on! Yeah, diba? Wala, nasa yung uniform ko? Okay, let's analyze this together. How can we teleport or jump at figure 20 and instantly arrive to the total number of matchsticks being used? In studying figure or number sequences, we need to find a pattern first. Then figure out a way, a rule, a model, an equation, a formula, or a shortcut tool to teleport in any figure that you want to be. One way is to start from figure 1. Just bear with me guys, okay? Walang iwanan. We have one triangle having 3 matchsticks. So we can represent one triangle to be our variable n. Or any letters you want, x or your x. This will be our first expression. Next, figure 2. Originally, this figure has 2 triangles. So we have 2 ends. But because we stick them together, we have here one pair of matchsticks that overlaps. So every time we see an overlap, we remove 1. So our second expression is 2n minus 1. How about figure 3? Because there are 3 triangles, there will be 3 ends. Is there an overlap? Yes, these 2 pairs, so we remove 2 matchsticks. Isa dito at isa dito. So our next expression is 3n minus 2. Now look, can we see a pattern? Actually, our first expression is 1n minus 0 because we don't remove any matchsticks. It follows that the expression on figure 4 is 4n minus 3. Figure 5 is 5n minus 4 and so on. Observe that if we subtract 1 from each of these numbers, the results are the numbers on the right column. It creates a pattern. Because of this, we can now teleport to figure 20 or figure 100. So what will be the expression of figure 20? It's 20n minus 19. How about figure 100? It's 100n minus 99. Now going back to the question, how many matchsticks are used in figure 20? We can now use the expression 20n minus 19. Since in the beginning we know that n is a triangle having 3 matchsticks, what are we going to do with 3? We substitute it to n and perform the operations. We have 20 times 3 minus 19, so we have 41 matchsticks in the 20th figure. Now you can even teleport at figure 100 or any figures you want. So at figure 100, we use 100n minus 99. Substitute 3 to n, that becomes 3 times 100 minus 99. That is 201 matchsticks. That's it. In short, every figure has its own unique expression. But wait, I have a secret to confess. Come closer. Sabihin ko, lapit pa, lapit. Sige, lapit pa. There is one expression that fits for all figures. What? Yes, there is one. I will tell you. Going back to our figure sequence, we can directly count the number of matchsticks from figure 1 to figure 4. So figure 1 has 3 matchsticks, figure 2 has 5, figure 3 has 7, and figure 4 has 9, and so on. So 3, 5, 7, 9. Did you see the pattern right away? Yes, we just keep on adding 2 to the previous number repeatedly. Plus 2, plus 2, plus 2. Paulit-ulit, ng paulit-ulit, ng paulit-ulit. We call this constant 2 the common difference or the interval. So instead of adding 2 repeatedly, why not multiply the figure n, whatever figure you want to teleport, multiply it by 2 para diretso, right? To make things clear, n here is the figure number, okay? Not the number of triangles, not the number of matchsticks. So our initial expression is 2n. Let's check figure 1. It has 3 matchsticks. Let us verify if our expression works. If n is 1, we have 2 times 1. Is it equal to 3 matchsticks? No, it's not. Now, how about figure 2? If n is 2, that is 2 times 2, is it equal to 5? No. If n is 3, 2 times 3 is not 7. And if n is 4, 2 times 4 is not 9. So what have you noticed? Kapos tayo lang isa. No? Kapos tayo ng isa lagi. So our initial expression 2n is not enough. What are we going to do with it? We have to do a little adjustment. Dahil kapos tayo ng isa, we have to add 1 to our expression to satisfy our number sequence. So the expression that fits to all is 2n plus 1. We call this the formula for the nth term of a sequence or the general formula of a sequence. Now we can use the general formula to teleport to figure 20. So n is 20, 2 times 20 plus 1 is equal to 41 matchsticks. The same answer from our previous process. Let's try figure 100. N is 100, so 2 times 100 plus 1 is 201 matchsticks. Activity 1. Now try this figure sequence. Number 1. Identify the general formula and find the number of matchsticks required in figure 55. And number 2. Identify your nth term formula and find the number of matchsticks required in figure 154. Do you still recall your grade 8 lesson in functions? 2n plus 1 is what kind of function? It follows the same format as y equals mx plus b, right? Where m is the slope and b is the y-intercept. Therefore, 2n plus 1 is a linear pattern where m or the slope is equal to 2 and 1 is the y-intercept b. What does x represent? It's n or the figure number. How about y? It represents the number of matchsticks because 2n plus 1 is a linear pattern. What is the shape of its graph? It's a straight line. How will you know that the given figure sequence is a linear pattern or not? Let's examine this one. We simply make a table. The first column is for the figure numbers and the second column is for the number of matchsticks. So figure 1 has 4 matchsticks, figure 2 has 7, and 10 matchsticks. Is this a linear pattern? A simple test will do. Just get the interval or the common difference of the second column. It's a constant 3. We are just adding 3 each time. Therefore, this is a linear pattern. Again, make a table. The first column is for the figure numbers and the second column is for the number of squares. So figure 1 has 1 square, figure 2 has 4, then 9 and 16 squares. Get the interval. Is it a constant number? No, it's not. Therefore, this is a non-linear pattern. If we continue to get the interval, the second difference now becomes a constant. Actually, this is a quadratic pattern. If the third difference is a constant, it's a cubic pattern. For now, let's just focus on the linear patterns. Activity number 2. Identify if the given figure sequence is a linear pattern or not. Construct your table by adding columns to your first, second, or third difference. I hope you learned something today about finding the nth term or the general formula of a sequence and the process to identify whether a sequence is a linear pattern or not. Congratulations! See you in our next video. Stay safe, stay home, and stay productive. God bless. Bye-bye!